We're surrounded by these hidden forces. They're literally everywhere, shaping our world in ways we don't even notice. We're talking about why things fall, how things stick together, and basically how our modern world even works. Today, we're going to pull back the curtain on one of the most powerful of these hidden forces. Okay, let's start with something super simple. Your fridge, right? You walk up, slap a magnet on it, and it just sticks. No tape, no sticky stuff, nothing. So what gives? What is that invisible glue holding it in place? Well, the answer, in a word, is force. It's all about the pushes and pulls that secretly run our entire world. Now, some forces are pretty obvious, but others, like the ones sticking that magnet to your fridge, yeah, that one's totally invisible. So it turns out, scientists basically group all these forces into two main categories. You've got the seen and the unseen. All right, let's break this down. It's actually pretty straightforward. On one hand, you have contact forces. These are the direct ones. They have to physically touch something to work. Think about friction, the force that stops a book from sliding across a table forever. On the other hand, you've got non-contact forces. And these are the really cool ones, the ones that feel a bit like magic, because they work over a distance without anything touching at all. And yep, you guessed it, magnetism is a classic example. So let's circle back to that magnet on your fridge. That invisible glue? It's a non-contact force. The magnet is literally pulling on the metal door right through the air. And what does that remind you of? Well, it puts it in the exact same club as another huge non-contact force you deal with every single second, gravity. Seriously, the same kind of invisible pull that keeps your feet on the ground is what's holding that grocery list up on your fridge. Okay, so we've named the culprit, magnetism. But how does it actually work? Let's dive in and finally solve this fridge mystery. All right, here's the secret sauce of every single magnet. It's called polarity. You see, every magnet, no matter how big or small, has two special ends. We call them the North Pole and the South Pole. And that's where all the action is. It's where the force is the absolute strongest. And these poles live by one simple golden rule. It's so fundamental. Opposite poles attract. And like poles, well, they repel. It's kind of like a law of the universe. A North Pole and a South Pole, they can't help but pull toward each other. But try to force two North Poles together? No way. They will actively push each other apart. That's repulsion. So where does all this pushing and pulling actually happen? It takes place in an invisible area around the magnet called a magnetic field. I mean, you can literally think of it like a sci-fi force field. It's this bubble of influence that stretches out from the poles. And the second another magnet or a piece of metal enters that field, boom, it feels the force. That's the magic right there. But this is so much bigger than just fridge magnets, right? This invisible force is a cornerstone of our entire modern world. Let's look at how this one simple idea powers some truly world-changing stuff. Okay, let's scale this up, like to the size of a planet, because that's how a compass works. Believe it or not, the Earth itself is one gigantic magnet. A compass needle, that's just a tiny little magnet that's free to spin. And its North Pole is constantly being pulled by the Earth's magnetic field, so it always points north. I mean, how cool is that? It's ancient navigation, all powered by planetary physics. And it gets even bigger than that. What happens when you mix magnetism with electricity? Well, you get the electric motor, one of the most important inventions ever. Basically, by using magnets to constantly push and pull on electrical currents, you can create motion, you can make things spin, and that simple idea powers, well, pretty much everything, from your blender to a fan all the way up to electric cars, all thanks to this invisible force. So when you think about it, it's pretty incredible. That simple, non-contact force sticking a note to your fridge is the very same principle that guided ancient explorers across oceans. It's the same force that's at the heart of the motors powering our world today. These invisible magnetic forces, they're not just some neat science trick. They're absolutely everywhere, quietly running everything. And that really makes you think, doesn't it? We've just scratched the surface with magnetism. What other incredible invisible forces are out there, hiding in plain sight, just waiting for us to notice?